Alright, method 1, rotating 100 degrees about the origin. I picture these little hooks that come out and meet that because for some reason I can picture this straight line going 180 degrees better than I can this line. So this straight line is going to go 180 degrees and curve around this way, and that little hook's going to come with it, so that Z will end up down there, and that'll be Z prime. And so the whole thing just kind of curves around. We're going to do the same thing with this hook. So it's 5 and 1, so that all goes around and it's 5 and 1, 2, 3, 4, 5 and 1. So that's there. And now you can kind of start to see that everything's going to fall in place. Like that length should be B, should be for B, and then this length here for K, and everything follows around. Okay, so we have that. If we had like wax paper, you could do one of the things where you kind of mark the origin and then trace your graph and then spin the paper 180 degrees, and that's what you're trying to picture. So it does end up overlapping what we got. That's kind of cool. So from there to there. So another way, if the visualization's tough or if the graph has too big of numbers, we learn these neat tricks. We learn that if you're rotating 180 degrees about the origin, the x and the y just change signs. So xy becomes negative x, negative y. So the way your transformation looks, txy becomes negative x, negative y. So if our original point was negative 3, 5, then our new point is 3, negative 5. And our new point, if our old point was negative 1, 5, our new point will be 1, negative 5, 1, negative 3, 3, negative 4. And so you can see that those points are indeed matching up with this new graph down here. So 3, negative 5, 1, 2, 3, 1, 2, 3, 4, 5, that's that point there, check. 1, negative 5, that's that point there. 1, negative 3, that's that point there. 3, negative 4, that's that point there. Oh yeah. So that's very, very nice, right? And there's no reason to complicate it, except I am. So, and that's fine for high school geometry, but if you want to go a step farther, they've also got this on our cheat sheet. 180 degrees about the origin, we could use this matrix transformation. We could multiply the points in our matrix by that guy there. So I could take, and I could either do this all at once, like take every point and multiply by the matrix there, or I could do it point by point, which is what I have set up here. So the matrix they gave us, our transformation matrix for this is negative 1, 0, 0, negative 1. And so if I take each of my original points and I multiply them by this matrix, I'll get my new points. So rows by columns, 3 plus 0 is 3, 0 minus 5 is minus 5. And you see that that is 3, negative 5, that was our new guy, right? So these are kind of boring matrices. So we'll do it again, rows by columns, 1 plus 0 is 1 plus 0 is 1, yeah. And then rows by columns, 0 minus 5 is minus 5. And then rows by columns, 1 plus 0 is 1 plus 0 is 1. And then rows, columns, 0 minus 3 is minus 3. And we get the gist, right? This will be 3 and negative 4. So it just ended up changing the signs like we knew it would. And again, I did them all separately here, but the way they show it on our cheat sheet is that you can do them all at once. So I'll show you that. So if we took all of our original, oops, I'm writing way up there. If you took all our original ordered pairs, we had 3, negative 5, negative 1, 5, negative 1, 3, and negative 3, 4. And we multiplied that by our matrix transformation, negative our transformation matrix, -1, 0, 0, -1, we would get, so rows by columns, -3 plus 0 is -3, and then I'll do this column as well. 0 plus 5 is 5. Move on to the next row. 1 plus 0 is 1. 0 minus 5 is -5. And it's going to be longer, right? Because this was a 4 by 2 times a 2 by 2. So we're going to get a 4 by 2. 4 by 2. So we have that times that. 1 plus 0 is 1. 0 minus 3 is -3. 3 plus 0 is 0. 3 plus 0 is 3. Haha. And then 0 minus 4 is -4. So again, we're just getting the boring, it swapped signs. So let's see, what else do I want to say? I think that's it for that one. So, so the rotation matrix in this one was kind of boring. It's like, why are we doing it like this when we could have just done it like that? But that's because you can do some neat things with these matrix transformations, and sometimes it's easiest to start with the little ones that do something that you recognize versus the weird ones that do something just random. So so we'll learn to rotate with interesting angles and just do neat warpy things. Okay, that's it.